Hey guys, welcome to the first video of DSA to Dev series. We are going on with Trie data structure today. It is a tree-like data structure also known as prefix tree or digital tree. Why it is important? Because it provides us some operations like insertion, deletion and searching all in nearly constant time, or you can say we go of k, where k is the size of the word we are working on. So it is an efficient data structure where overlapping words are stored efficiently with single time, and rest, if the differences occur, they branch in different paths. Rest all is saved only once. So the basic operations are insert, delete and search, which are done in big of n. Suppose n is the size of the word we are working on. The uses of try, autocomplete and predictive test, which you can see in the search bar. Spell checks in platforms like Grammarly, you can see spell checks. They work with try because if you type in a wrong word, they search for the word in the dictionary and no similar word is found, so they show an error. IP routing, it is an advanced concept of routing table where try is used to store the starting of prefixes, which will help to optimize the searching of IP and sending packets here and there. And dictionary lookup is similar one where we search for words. Suppose we type in the word CAR and you will see CART and care. That's what autocomplete or auto suggest is. Before moving on further, I'll explain you the structure of try node. Here, how try node works is, let us suppose a node is there. So it will have a array of 26 size, a character array, A to Z represented by 0 to 26 size of the array. Suppose we have to store A, we set the 0th index as 1 or true. After that, it has one variable, Boolean variable, is end of word or is end word, which means if it is true, then that particular word ends here. So we trace back to the path we came from root and we find one unique word. If it is false, nothing matters. Okay, so this much introduction is enough, I think. Now we will go to a very unique and good tool I used during my college days, where I use this website to visualize data structures. Like here, let me open try. Suppose we need to add the word apple, a very common word. What will happen? So a root node, empty root node will be there, and the keyword APPLE will branch down as no node is already existing. So let's insert. As I said, this is working, and the last E is set as color filled green, which means the last character E is end of the word, set true. So if we trace down in the tree from root and find this path, whenever we reach E, we will return the prefix and that word will be apple. Now suppose we insert ape, APE. What happens then? Then it will branch from P in the left because of alphabetical manner, and E will be added, which will be of filled green. Okay, as you can see. Similarly, let's take one another example. Apps Let's take one more, apply. It will branch from P and add Y. Sorry, it branched from L. Okay, so this is the basics of Trie. Now we will implement it in development. Okay, to continue in the video, we will start with creating a new folder. I am working completely from scratch. Let's open that folder in VS Code. Right click, open with code. Okay, after the folder is opened, in the architecture we will have two folders, one frontend, another backend. Frontend will serve the React and backend will serve the Express. Backend. Let's set up backend first. Open new terminal. cd backend npm init -y, yes to all the questions. It will create a packet.json file in the backend. Now you can see here. Now let's install the required packages, which are Express, NodeMon and CORS. While it is installing, let's create a file called index.js. Index.js. This will serve as the entry and exit for our server. Let's import the package Express. Import Express from Express. Import CORS. Okay. After that, const app equals to express, const app.use CORS. Let's define a variable port. Const port equals to 3000, app.listen port. Let's also create an API at home route to serve the front end and verify if the backend is working. App.get at home route say hello.world. Okay, let's make some changes in the packet.json. First, here adding type as module, so the import commands will work very well. After that, add a start script and a dev script. So we added the dev script. Now let's try running the server. Npm run dev. Okay, it is working fine. Let's verify if it is running or not. Open Thunder client and create a new GET request at localhost 3000. Okay, http://localhost:3000 types. Okay, hello world, we got the response. That means server is working fine. Now let's create the controller for our auto suggest feature. This will have the file for Trie controller .js. Create the class Trie node. To create an empty node, class Trie, which will have all the functionalities. Call the constructor with Trie node, and let's define the insert function with word as input, in which take current node as the root, and then if a word exists, then we do nothing, and if word does not exist, we create a new node and add that word as value. And after the loop finishes, we set is end of word as false. Okay, after the insert function we will create an underscore DFS function which will search after the prefix all the possible words, like if we type CA, then all the words from CA will be searched and returned as result. It is working recursively. After that we will create the autocomplete with prefix input. Okay, it returns result. Let's export the try. Okay, now we have to create a folder called routes. In this we will have routes file for autosuggest.routes.js. Okay, so in this file let's import the router from Express and import the try from try controller. Then create the router, create the try, create a words array that will serve as input for our try. Okay, now we will add the API for our autosuggest. Okay, it should take the prefix as input from the params autosuggest, not say prefix. Okay, from params it should take prefix. After that export the router. Now we will import this router in our index.js file through app.use feature. App.use. Let's first import the file. Import autosuggest routes from autosuggest routes.js. Then add slash. Let's see if there is autosuggest. No. Slash autosuggest app autosuggest routes. So let's check once again if it is working. Autosuggest slash C. Okay, the server is not working. The issue is with the array. Okay, we forget the term const to define the words. Control save. Okay, so now we correct the word. I added the const. After that, let's check in Thunder client if the request is working or not. It is working. What is the output? Cherry for C. Let's check for A. Okay, so it's working fine. Now we will add Frontend folder. Okay. Okay, so I have cleaned the code. Now let's create the functionality for autocomplete. H1 autocomplete. Class name. Now we will create a folder pages. In this pages, let's create the autocomplete.jsx. In this, we will import use effect and use state from React. Use state, use effect from React. const autocomplete. We create the 3 states for it. First one is input, second is suggestions, third is debouncing input. If you do not know what is debouncing, in JavaScript we create debouncing which serves in a use effect to change the timeout for sending a particular request. So here 300 millisecond. How it works? Suppose you are typing, and if you provide a gap of 300 millisecond in the typing, then a request will be hitted on that. If you keep on typing, no request will be hitted. Then we create a use effect for calling the API and this. Okay, now let's export this component and call this in our app.jsx autocomplete. Let's see how it works on Chrome. Localhost 5173. Okay, it is not running by now because we have not yet started the frontend. npm run dev. Okay, let's reload autocomplete. Let's check if it is working. It's working completely fine. Let me make some UI changes. Okay, so it is working fine. We can add more word or source any dictionary from an API. Right now I am completing this video. If you like the content, hit like, subscribe the channel, and whatever is your feedback, comment that. I will definitely work on that. Okay, bye.